Good morning, you guys. It's Miss Silva again. Here is our second lesson working with Pythagorean theorem. So if you remember from our last set of notes, Pythagorean theorem says that if you take the right triangle that you are given, has to be a right triangle, and you square the smallest side, you square the medium side and add those together, it's going to be equivalent to the square of the largest side. So that's going from information in our triangle to being able to solve it. But here what we're going to do is we're going to actually take a look at the converse of the Pythagorean theorem. So the converse means that we're going to be working backwards, okay? So instead of solving for a missing side, we're going to be given all three sides and determine if it is a right triangle. So again, some of these numbers get a little bit large, so I'm going to keep my calculator handy as we work through these. So you can definitely see that these triangles do not have that right angle notation because that's what we're trying to prove. We're trying to say, is this a right triangle? So with that being said, where you might assume the right angle would be, keeping in mind kind of across from that, that's going to be our largest side, side C. I'm going to just I'm not going to note that it's a right angle, but I'm going to keep in mind that that's probably where it would be, just so I can figure out my sides. So we've got 8, that's the shortest side. 15, that's the medium side. So again, we're thinking about squaring these sides. So that means we have to do 8 times 8, and then squaring this side, 15 times 15. So we have to remember squaring it. And we want to know, does that equal 17 squared? So 8 squared, I know that is 64. 15 squared is 225. And when I add those together, does that give me 17 squared? What is 17 squared? 289. So a little bit of addition over here, 225 plus 64 does give me 289. So when we see that those two are the same, makes us happy. What we can say is that yes, this is a right triangle. Okay, so instead of being given a right triangle and solving for a side, we're working backwards. That's the converse. We're given all of the sides, use the formula and see if it does balance on both sides. So let's take a look at the next one, moving across here. So we've got, I think that's probably the right angle there. So this is going to be my side C. So the smallest side squared plus the medium side squared, does that equal the largest side squared? And again, we're questioning that, so I'm going to put a question mark. 16, 144. Does that equal 169? Let's see, 144 plus 16 is 160. So what we're going to see here, these are not equal, so we would answer that this is not a right triangle. Okay, so we cannot put any kind of a right angle notation in there. What we've seen is that those sides do not work. Let's take a look at this one right here. Again, we're going to skip some of these examples here because this is kind of a longer worksheet, and I'd rather get through some of the other examples too. So again, I think this is where the right angle is, so this would make this C. So the smaller side squared plus the medium side squared, does that give us the largest side squared? So 16 plus 49, does that equal 121? Let's see, 9 and 6 is 15. 65, nope, definitely not the case. So this is not a right triangle. Okay, so Again, this is the converse of the Pythagorean theorem. We're given just a random triangle with all three sides labeled in lengths. Using the Pythagorean theorem, does it balance on both sides? So that'll be a yes or a no. The rest of the questions here on the front side we're going to see are very similar to what we did in the last set of notes. So we're going to take a look at A and B on the front side here, and then I'm going to switch over to the second side of the notes. So we've got 6, 8, we've got an unknown side here. This is labeled as 90 degrees. So again, knowing that that's 90, this is my side C, which is unknown. I'm just going to ignore these little vertices that are labeled here. So my small side 6 plus the medium side 8 squared equals C squared. 36 plus 64 gives us a total of 100. And then remember, to solve that equation, we'll do opposite operations, square root both sides, and that gives us 10 inches as our value for C. And then on the front side also, we'll take a look at this one, example B. So let's take a look. 90 degrees, so this is side C, and this is our unknown right here. I'll just call it X. So my smaller side plus the medium side, which is unknown, and then my largest side, 5. And again, we square each of those sides. These are nice small numbers that we can square nicely. Mental math. Solving this using opposite operations, 25 minus 9 is 16. And then solving this square root equation, take the square root of both sides, gives us our value of 4 meters as that missing length. So that was just a little bit of a recap of what we did last time. Again, some of these examples I'm going to skip through just so that we can get to some of the other ones on the back side. So I'm going to skip on the front side of this worksheet, or on page 1, I'm going to skip C and D and take a look at E. So we saw with A and B that these definitely were right triangles. We were told right there in the sentence. We saw that notation there. So again, we really have to look at the wording with the problems, because it could be that they're giving us more information than what's just in the picture. So example E says, find the length of the hypotenuse. Hypotenuse is the largest side of the right triangle. Okay, so that's what it's called. It's called the hypotenuse. So find the length of the hypotenuse, the largest side, in the right triangle below. So we are told this is a right triangle. So that means that because I'm told in the directions it's a right triangle, I can go ahead and draw that in. So that tells me that here's my side C. That's what I'm solving for, the longest side, again called the hypotenuse. Smallest side squared plus the medium side squared equals the longest side squared. So 25 plus 144. Here we've got two numbers to add together. And then to solve that squared equation, we'll square root both sides. And that gives us 13 meters as our value for C. Similar with F, we were told that it's a right triangle, so you could draw that in there. And then same thing, I'm going to scoot this paper here. Same thing with G. I'm going to take a look at example H next. There's no picture with this, so from the information that's given to us, I'm going to go ahead and fill in that information. I'm going to just make a sketch over here on the side. A right triangle. Okay, so I know I've got a right triangle. Put in that right angle notation. Has a hypotenuse of 10 inches. Remember, hypotenuse is defined as the largest side of the triangle. So this is 10 inches. And one of the legs is 3 inches. Excuse me. Now, I don't know if that's the small side or the medium side. 3 sounds like it's a small, so I'm going to put it here next to the smaller one. But again, this is just a sketch. It doesn't have to be absolutely accurate. And then here's my other side, my other leg of the triangle. Smallest side squared plus the medium side squared, again, those are called legs of the triangle, equals the largest side squared. Again, we call that the hypotenuse. So that's 9, and that's 100. When we subtract 9 on both sides of the equation, it gives us x squared equals 91. Now, we've been really fortunate in these examples that we've done that when we take the square root at the very end, it's been a perfect square. When I take the square root of 91, I have no idea what that is. So if you remember from last week, we did some estimating with squares that weren't perfect. For the sake of solving these right triangle problems, we're going to go ahead and put those non-perfect squares in the calculator. So if we were to find the square root of 91, again, in my calculator, I have to put the square root sign first and then 91. In your calculator, you might put 91 and then hit the square root button. The square root of 91 is a very long decimal. We're going to go ahead and round to the nearest tenth. That's what we did when we estimated those non-perfect squares last week. So 9.53, when we round to the nearest tenth, that 3 is going to tell the 5 to stay the same. So that tells us that 9.5 inches is the side that is missing from this triangle. All right, the last two examples that we're going to work through, a little bit more complex. So for example 3, in the figure that's drawn over here at the right, we're told that H is the halfway point of the segment JK. Okay, so that's the halfway point. It's labeled as 16 meters all the way across. And it's the halfway point. So that means by reading that sentence, I know that this is 8 units and this is 8 units. Segment JK is 16 meters, already labeled there for us. And we're asked to find the length of the segment LH. We are asked to find this segment right here. Okay, so I know since this is the halfway point, this is 8. I've got 11 meters right here, so I'm going to take this big triangle and kind of just focus on this upper part of the triangle. Okay, so I'm going to take and actually redraw this over here on the side. L to H, that's my unknown. And then we said this was 8 meters. There's my right angle notation. And then we've got this drawn, and it's 11 meters. Okay, so there's our right triangle. So across from that right angle is my value for C, the longest side of the triangle. The shortest side is 8. We square that. The medium side is unknown. And then the longest side is 11. Again, we're always squaring those sides. If you remember, it's like we were drawing out squares from each of those sides. 64, 121, and then to solve this equation, subtract 64 on both sides of the equation. And that gives us 57. So again, taking the square root of both sides, we're going to see 57 is not a perfect square. So I'm going to go ahead and use my calculator for this again. The square root of 57 is, rounding to the nearest tenth, 7.5. So x is equal to 7.5 meters. All right, last example that we'll take a look at working with our Pythagorean theorem converse. Segment MN, this one right here, and segment PR are perpendicular. Perpendicular, if you remember, that means that it is 90 degrees. So I'm going to go ahead and draw in a right angle on this side. And we could draw one in on this side also if we wanted to. What is the length of segment MP? So this is our unknown right here. So that means that I'm going to need to work with this number, and ooh, in this triangle right here, I don't have this length. All I know is that this entire thing is 14. That doesn't help me too much. So what I'm going to do is I'm going to do this in steps. I'm going to take a look at this smaller right triangle first, and I'm going to redraw it over here, 13, 12, and this is the unknown. I'm going to look at this one right here first, this right triangle. So using Pythagorean theorem, here's my side C. So 13 squared is the longest side. Oops, sorry. X is my smallest side. 12 is my medium side. 13 is the longest. So solving that, 144. 13 squared is 169. Subtract 144 from both sides, and that gives me, let's see, 25. And taking the square root of that on both sides, x is equal to 5. So what I found in my first step is that this value right here is 5. That helps me out a lot because I know the entire length, MN, is 14. If this much of it is 5, then that must mean that this part right here is 9. So now my second step, I can look at the larger right triangle. So the larger right triangle I just found from M to R is 9. R to P, that's my right angle. That's a value of 12. And then this part right here, this is my unknown. So I actually had to do one step beforehand before I could actually work with the triangle that I needed to solve. Right angle, across from that is my unknown. So again, my longest side. Shortest side is 9. Medium side is 12. Longest side, unknown. That's 81. That's 144. Adding 144 to 81 gives me a total of 225. And when we take the square root of that on both sides, 225 is actually a perfect square. 225, the square root of that is 15. Okay, so C is equal to 15. We didn't have any labels here. I'm going to just call it 15 units. Okay, so that was our missing side there. So again, in summary, the second set of notes was us working on being able to determine if a triangle is a right triangle based on those 3 measurements, the 2 legs and the hypotenuse. And we did that converse of the Pythagorean theorem. Hope you guys have a great week. I'll see you again next week.